Okay, we're going to start again. Just a little bit where I've touched it so we can start. Hopefully this is working. Okay, partial auxiliary views. Using auxiliary view often makes it possible to omit one or more regular views, but auxiliary views or auxiliary drawings are time consuming to create and may even be confusing because of the clutter of lines. Partial views are often sufficient and easier to read. So, if you remember, I told you that earlier that your surface that you're looking for, or you're trying to draw true size and true shape, is the only part of that that auxiliary view is going to be true size and shape. The rest of it is not. It's going to be out of shape because of the way you turned it. So I guess in this case they would say you can eliminate that part, so you wouldn't have to spend all that time trying to draw that at a weird angle. So on the left hand side, excuse me, you have a front view, you have a partial right side view. They're just showing that bottom part. They're not spending time trying to lay out an elliptical arc or an elliptical circle in that side view. And same thing with the top view. They're just doing a partial top view, and they're not trying to waste time trying to draw those weird angles. But they show that upper part in true size and shape in the auxiliary view. And you notice they don't draw the bottom part. That would, in the auxiliary view, that bottom part would be out of shape, not true size and shape. The only part that you're looking for is that upper part. On the right hand side, they got the same thing or similar thing system here. You got a partial bottom view, which is and the front view at the top. They got a front view and a bottom view in this case, and they can show the true size and shape of that area on the right hand side. This ellipse and the circle, or not the ellipse, the arc and the circle. On the left, it's kind of skewed because it's turned at a angle. You can see that in the right hand side where they got the partial, okay, with auxiliary view. They just drawing the bottom part because that's all they're interested in, is showing the true size and shape. They're not drawing that area to the right. And then there's the right hand side view. Okay. Auxiliary sections. An auxiliary section is simply an auxiliary view and section. Note the cutting plane line and the terminating arrows that indicate the direction of sight for the auxiliary section. In the auxiliary section drawing, the entire portion of the object behind the cutting plane line or cutting plane may be shown, or the cut surface alone may be shown. So they're projecting the line up to where it says auxiliary section AA, from AA, cutting plane line AA, and they're able to draw a section of that part at AA. Again, they only show a partial view in the top view there on the left, and it appears that they're showing the whole right side view. So you got a front view, side view, and a partial top view, and then that auxiliary section view. Viewing plane lines and arrows. When the drawing sheet is too crowded to show the auxiliary view in direction projection, you can use a viewing plane line or a viewing plane direction arrow to indicate the direction of sight for the auxiliary view. So you have your drawing on the left, and then you come over here, and they basically, it's not a auxiliary view per se. It is, but it's basically they're showing you where how you're looking at that part. With appears to be cutting plane lines, but in this case, it's not cutting plane lines. They're viewing plane lines, and they're showing the direction where you're viewing at. Okay, so to the upper right of that, where it says View AA, and that's where your auxiliary is, and you can see the true size and shape of that surface. True length of lines, this is where it gets kind of weird for you, so we're probably not going to spend a whole lot of time on this, but true length of a line, to show a true line, true length, to show a true line, true length, show a line, true length rather, make the fold line parallel to the line you want to show true length in the auxiliary view. Whenever a line is parallel to the fold line between the two views, it will be true length in the adjacent view. So just look at that and kind of get an idea. We'll try to get an idea. It's kind of confusing. We're not going to spend a whole lot of time on it. Point view of a line. Excuse me. To show the point view of a line, choose the direction of sight parallel to the line where it is true length. Okay. Again, this is another one of those confusing things. We're not going to spend a whole lot of time on it, but we'll go through it real quickly. Choose the direction of sight to be parallel to line 1, 2. Okay. Draw folding line HF between the top and front views as shown. So there, between the front view and the top view, there's line HF. Draw folding line FI perpendicular, F1 what is it? It's F1, it looks like. Perpendicular to line 1, 2. Okay. Where it is true length, and any convenient distance from line 1, 2 in the front view. Draw a projection lines from point 1 and 2 to begin creating the auxiliary view. Transfer points 1 and 2 to the auxiliary view at the same distance from the folding line as they are in top view along their respective projection lines. They will line up exactly with each other to form a point of view of the line. So good luck. Edge view of a plane. To show the edge view of a plane, choose the direction of sight parallel to a true length line in the plane. Okay, so choose the direction of sight to the parallel to line 1, 2 in the front view where it is already shown true length. Okay, so there's line 1, 2. Draw a folding line F1 to the right true length line 1, 2 and any convenient distance. Okay. Draw a projection lines from 1, 2, 3, and 4 to begin creating your auxiliary view. Transfer points 1, 2, 3, and 4 to the auxiliary view at the same distance from the folding line as they are in the top view along their respective projection lines. Planes 1, 2, 3, and 4 will appear on the edge in the finished drawing. Okay, I think this is, we're not going to talk about this too much. This is true size of an oblique surface. Showing the true size of a surface continues from the method presented for showing inclined surfaces true size. where the edge view is already given. But to show an oblique surface true size, you need to first show the oblique surface on the edge and then construct a secondary auxiliary view to show its true size. Again, we're not going to get into this. Just be aware of it when you're doing your quiz. Okay, we're going to stop right there. Over 10 minutes now.